Hey guys, welcome everyone. Hope all are doing fine. And this is Nithin from 1VE CSC, and I'm here today to present you a PPT on Introduction to Data Mining and Data Warehouse, Multidimensional Model, and difference between OLAP and OLTP. So let's don't waste time and get started immediately. So now, first of all, we start with introduction to data mining. So in this process, the data is extracted and analyzed to fetch useful information. In data mining, hidden patterns are researched from the dataset to predict future behavior. Data mining is used to indicate and discover relationships through the data. So the data mining uses statistics, artificial intelligence, machine learning systems, and some databases to find hidden patterns in the data. It supports business related queries that are time consuming to resolve. So here at the bottom of the slide there is a graphical representation that includes there is a specific amount of data that is undergoing selection, and the data will convert itself into the targeted data, and the targeted data again will be pre-processed, so it becomes the pre-processed data. And after the transformation of the pre-processed data, we'll get a transformed data, and the transformed data after undergoing data mining become a pattern or a model. So this after interpretation evaluation is knowledge. So this is so let's move on to the next slide. So here we have the features of the data mining. So data mining software features for the dark data. So there are almost 6 features. So the first feature is data extraction. Data extraction allows you to analyze and crawl your data in a pattern to help you organize. So then is data visualization. So it allows you to feed real-time data as it's fine to a supervisor computer. So the third feature is linked data management. It allows you to provide a set of guidelines to organize data that is connected. So then the fourth feature is machine learning. Extract useful patterns from your data. It's a vital feature. So then there is a semantic search that allows you to search your data with contextual terms instead of data languages. So there's a sixth feature called text mining that allows you to derive high quality information from your text databases. So these are some features of the data mine. So let's move on to the next slide. So here there are the advantages of data mining. So here there are some advantages of data mining. So here the first advantages of data mining is fraud detection. It is used to find which insurance claims, phone calls, debit or credit purchases are fraud. Okay. Then there is a trend analysis. So existing marketplace trends are analyzed, which provides strategic benefit as it helps in reduction of cost as in manufacturing for demand. And there is one more advantage called market analysis. It can predict the market and therefore help to make business decisions. For example, it can identify a target market for a retailer or certain types of products desired by the types of customers. So all this. So moving on to the next slide, we have data mining techniques. So there are several data mining techniques that it is used to fetch the appropriate information from the data set and to segregate different classes that are present in the data set. So below there are classification models, and the first model is k nearest neighbors, and the second model is the support vector machine, and the third model is Gaussian naive Bayes, and we will not go into deep about these concepts, so we'll go on to the next slide. So the next slide is data warehouse. A data warehouse is where data can be collected for mining purposes. Usually with large storing capacity, various organization systems are in the data warehouse where it can be fetched as per usage. So there is a source, and the source is in extract, and the extract after transform, and the transform is loaded, and the loaded is targeted. So this is the process where data warehouse actually operates. So data warehouses collaborate data from several sources and ensure data accuracy, quality, and consistency. System execution is boosted by differentiating the process of analytics from traditional databases. In a data warehouse, the data is sorted into a formatted pattern by type and as needed. The data is examined by query tools using several patterns. Data warehouses store historical data and handle requests faster, helping in online analytical processing, whereas a database is used to store current transactions in a business process that is called online transaction processing. So this is all about the data warehouse, and there are some features of the data warehouses. The features of data warehouses includes subject oriented. It means it provides you with important data about a specific subject like suppliers, products, promotion, customers, etc. Data warehousing usually handles the analysis and modeling of data that assist any organization to make data-driven decisions. So there is one more feature called integrated. Different heterogeneous sources are put together to build a data warehouse, so such as level documents or social databases. So there's a time variant feature. The data collected in a data warehouse is identified with a specific period, with a specific time period. So there is a non-volatile feature. This means the earlier data is not deleted when new data is added to the data warehouse. The operational database and data warehouse are kept separate, and thus continuous changes in the operational databases are not shown in the data warehouse. Then we have the applications of data warehouse. The applications includes which are all the domains that the data warehouses are being used in day-to-day life. So in banking, the data warehouse is used in keeping of records of accounts and customer information performance, recognize possible default risk, and manage and regulate collections. So in healthcare, it creates records for the patients, employees, and finances, shares the information with other institutions such as insurance companies, non-governmental organizations, and medical aid providers. And in government domain, it maintain and analyze tax records, health insurance information, and the providers that supply them. Criminal activity prediction based on patterns and tendencies. So in education field, information on teachers and students is stored and processed by data warehouses. Maintain student portals to help students with their activities. So in insurance domain, create personalized officers and promotion for clients, predict and evaluate industry changes. And in finance, the data warehouses are used in trends in consumer expenditures are being assessed, ensure transaction transparency. So in retailers, keep track of manufacturers and customers using data warehouses, and recognize the trends in complaints, claims, and refunds. And in the manufacturing domain, the data warehouse is used to analyze existing business trends and forecast market developments, examine historical and current market statistics. So these are the applications of the data warehouse in which it is used in day-to-day life. So moving on to the next slide, we have multidimensional model in data warehouse. The multidimensional data model is a method which is used for ordering data in the database along with good arrangement and assembling of the contents in the database. The multidimensional data model allows customers to interrogate analytical questions associated with market or business trends. Unlike relational databases, which allow customers to access data in the form of queries, they allow users to rapidly receive answers to the requests which they made by creating and examining the data comparatively fast. OLAP, Online Analytical Processing, and data warehousing uses multi-dimensional databases. It is used to show multiple dimensions of the data to the users. It represents data in the form of data cubes. Data cubes allow to model and view the model from many dimensions and perspectives. It is defined by dimensions and facts and is represented by a fact table. Facts are numerical measures, and fact tables contain measures of the related dimensional tables or names of the facts. So this is all about the multidimensional model in data, and we have the representation of the multidimensional data model. So this representation is for your reference, and look at it. So then we will be going on to difference between OLAP and OLTP. So OLAP and OLTP, the name suggests OLTP stands for Online Transaction Processing and OLAP stands for Online Analytical Processing. So now, first difference, the source of data. The OLTP operational is an operational data, and OLTPs are the original source of data. whereas OLAP is consolidation data. OLAP data comes from various OLTP databases. Now, the purpose of the data. The OLTP data is used to control and run fundamental business tasks, whereas OLAP data is used to help with planning, problem solving, and decision support. So, and OLTP reveals a snapshot of the ongoing business process, and OLAP reveals the multidimensional views of the various kinds of business activities. So, inserts and updates, the OLTP short and fast inserts and updates initiated by end users, whereas in OLAP, periodic long-running batch jobs refresh the data. So, the queries. With respect to queries, the OLTP relatively standard and simple queries returning relatively few records, whereas OLAP often complex queries involving aggregations. So, the processing speed. In the processing speed, the OLTP is typically very fast, whereas OLAP depends on the amount of data involved. The batch data refreshes and complex queries may take many hours. Query speed can be improved by creating indexes. And the space requirements. With respect to space requirements, the OLTP can be relatively small if historical data is achieved, whereas online analytical processing OLAP is larger due to the existence of aggregation structures and historic data requires more indexes than OLTP. And the database design, with respect to database design, the OLTP is highly normalized with many tables, whereas OLAP typically denormalized with fewer tables, use of star and or snowflake schemes. Backup and recovery. With respect to backup and recovery, the OLTP backup religiously. Operational data is critical to the run the business. Data loss is likely to entail significant monetary loss and legal liability. Whereas OLAP, instead of regular backups, some environments may consider simply reloading the OLTP data as a recovery method. So these are some differences between OLAP and OLTP. By this, I will end my session, and thank you everyone for spending your valuable time on my video. And this is Nithin, and I'm signing off. Have a great day.